In the previous video, we took a look at how to find the equation of a line parallel to another line given a point. We're going to do the same thing in this video. It's a little bit tougher though, because we're not going to immediately be given the slope like we were in the previous. And so we want to try to find the equation line passing through negative 3, 4, parallel to 4y plus 2x plus 7 equals 0. So notice that this is in the general form. And we have to put it into another form so we can find the slope. Recall that to be able to find the equation of any line, first of all, we need a point on the line, and then secondly, we need a slope. And the good news is we do have a point. We have negative 3, 4, but we don't have a slope given. And so what we need to do is we need to find the slope of this line right here. Now, a lot of students would look at this, or some students, not a lot, but they would look at this and say, okay, well, 2 is the number in front of x. And they would say that m is equal to 2, and that m parallel is going to be equal to 2, since parallel lines have the same slope. That is not true. The reason it's not true is because we need to make sure that the equation is in the form y equals mx plus b before we go any further. All right, so next thing we need to do is we need to put it into that form. So let me erase this. And to put it into the form, I'm going to isolate y. All right, so what I'm going to do is I'm going to subtract 2x from both sides, and I'm going to subtract 7. And that's going to give me 4y equals minus 2x minus 7. And then I'm going to divide by 4 to isolate the y. And so now we get the equation y equals negative 2/4, or negative 1/2 x minus 7/4. All right. Now, clearly we can see that the slope of this line is going to be negative 1/2 because it's the coefficient of the x. And not that we need it, but it never hurts to see that the y-intercept is negative 7/4. We need a parallel slope. And we probably recall that parallel slopes have the same slope. So the parallel slope is going to be minus 1/2. All right, so now let's go ahead. We're going to use this slope and this point. And let's go ahead and just throw them together. And we have our equation. Remember, we have our y minus y1 equals mx minus x1. And so if we do that and substitute everything back in, we're going to get y minus 4, because that's our value for our y, is going to be equal to minus 1/2 quantity x minus a minus 3, or we can suggest that this is going to be y minus 4 equals minus 1/2 x plus 3. Now, that's going to be our slope, our point slope form. Okay, and that's one of the two forms that it was asked for originally. So you probably recall that the problem asked us to write it in the point slope form, but now we have to write it in the general form. So let me show you the trick to be able to writing this in the general form. So usually what we do is we distribute. Okay, that's what we're going to do. So we're going to distribute the negative 1/2. So we get y minus 4 equals minus 1/2 x. And then remember 3. So if we have negative 1/2 times 3, that's just times 3 over 1. So that's going to be minus 3/2. Now, to put it in the general form, rather than adding the fractions together, what I can do is I can clear the fractions out by multiplying everything by the denominator, or everything by 2. So that way we can simplify. Okay. Now, when I say everything, I mean every single term within the equation by 2. And it's legal. Remember, if you multiply and divide the same thing, then what we can do is we can keep the equation the same. So that's going to be 2y minus 8 equals, and minus, now remember, 2 is the same thing as 2 over 1, so this would be minus 2 over 2x, and then minus 6 over 2. So I just multiplied the numerators by 2 and the denominators by 1. And of course, we can simplify those. So we get 2y minus 8 is going to be equal to negative 1x minus 3. And then finally, what we can do is we can move everything to the left-hand side, because remember, with the general form, we needed ax plus by plus c is equal to 0. All right, so to be able to get there, what we're going to do is we are going to erase that just because we need that to be plus. And so what I'm going to do is I'm going to add x to both sides. And then I'm also going to add 3 to both sides. Now, I know that x and y are different terms. They're unlike. So we're going to get 1x plus 2y, and then negative 8 plus 3 is a negative 5. And that's equal to 0. And that's probably the nicest way that we can put it into our general form. Okay? So just be certain that whenever you're entering these into your My Math Lab or whatever it is, that you put it into the form that's asked. All right. Now, let's take a look at the example of a perpendicular line. All right, so this is a problem that we saw earlier, except now I just changed one word and I changed it from parallel to perpendicular. So first thing we need a point, which we have, good, but we don't have a slope yet. But the good news is this is put in the y equals mx plus b form. Okay, and we know that the coefficient, if we have it solved for y, if we have the equation solved for y, then that means that the slope of this is going to be 4. Okay, so the slope of this line, I'm going to call it m, is equal to 4, but I don't want 4. What I want is I want the perpendicular slope. And we recall that to find a perpendicular slope, we need the opposite and reciprocal. Okay, and so we can think of 4 as 4 over 1. And so the perpendicular slope is going to be negative 1/4 if we flip that over. All right, so now that we have that, what we can do is we can form the equation of the line, both in the standard form, or sorry, both in the point slope form, as well as the general form. So y minus y1, which is 2, equals negative 1/4 quantity x minus 1, which is the other point. And so this is going to be our point slope. Next thing we're going to do is get it to the general form. So just like we did in the previous problem, we're going to distribute. So we're going to say y minus 2 is down negative 1/4 x plus 1/4. Okay, so negative times negative is positive. And then remember, 1 can be 1 over 1. Remember that trick. We're going to get rid of all the fractions by multiplying the entire equation by the denominator 4. And so if we do that, that's going to be 4y minus 8 equals negative 4 over 4x. So remember, we multiply the numerator by the 4, and we can say plus 4 over 4. That's going to simplify into 4y minus 8 is equal to negative x plus 1. And then finally, we can add x and we can subtract 1 from both sides. All right. We know that x and y are unlike terms, so we have x plus 4y minus 9 is equal to 0. All right, because these are like terms. Now, geometrically, and by the way, this is our general form. All right, so that's our answer. Now, geometrically, we know that the lines should intersect at right angles. Okay, so what we can do finally is we can use a graphing device to check this. Okay, so let's plot both of the lines and see if they are indeed perpendicular. Remember our first line, y equals 4x plus 1. Right, so I'm going to go to here and delete this and this, and I'm just going to standardize this. So we had y equals, all right, so there's our line. And let's see if the other line is going to be perpendicular to that. So remember, we had x plus 4y minus 9 equals 0. And check that out right here. That should be a perpendicular. It forms a 90-degree angle. Okay, if I zoom in a little bit, it certainly looks like it's going to be a 90-degree angle at all those points. So at least there's evidence to suggest that we're on the right track with this. If it was something like where we had, I don't know, something like 2, or maybe like, like y or something like that, then we could clearly see that this is not a right angle. But because it's like 4y, all right, that at least looks like it's going to form a right angle to us. So hopefully that helps you to be able to see how we can go through and deal with parallel and perpendicular lines. We're going to look at one more problem in the last video to where we find another perpendicular line, a little bit tougher than what we've been seeing so far, and that'll be it for this section.